Are we good to go? We're good to go. Can everybody hear me? Seems like it. Good morning. My name is Mario, and today we're going to talk about an interesting topic that I decided to call copy and pest. And now you might ask yourselves, what is that? What might that actually be? Before we have a look at what that really is, let me introduce myself real quick. My name is Mario. I'm a researcher and a postdoc at the University in Bochum. And I wrote my PhD thesis about client-side security, meaning browser security, cross-site scripting, and those things. So whenever you see an alert box popping up, that was probably me. I also created a company that is located in Berlin. We do penetration tests, consulting, and we're, of course, simply the best company in the world. I wrote some papers, wrote some books, did some talks in the past, and tweet then and when, and maintain a bunch of security-related projects. For example, the HTML5 security cheat sheet, and the DOM Purify project, which is supposed to be a client-side only XSS filter, and I think it's working quite well. I tweeted a bit, and if you have any questions after the talk or you want to reach out to me, you can just send me an email address. Now, the topic that we're going to be covering today, I hope, is fairly novel. At least I perceived it as a novel attack vector, and it's something that is a little bit weird. And it also requires a little bit of user interaction, but the user interaction that is being required kind of doesn't imply that there could be any security consequences. The attack also has a logo, which is extremely important. And that's the logo, thanks Ange. And it pretty much expresses perfectly what's happening here, because we take a piece of paper, and this piece of paper looks empty, and then we make a copy of it, and after having a look at the copy, we realize that there's something bad on there, which is a bug. Now, to be able to kind of explain to you what this whole thing is about, I decided to put the demo that I usually do at the end of the talk at the very beginning of the talk. Now let's think ourselves in the following situation. We have a user, and that user wishes to compose an email message and send it to another person. And during the process of composing this email message, the user decides to open Word or some Office software, copy something from out of there and throw it into the editor, so it would become part of the email. Now let's have a look what happens here. Here is OpenOffice, or actually LibreOffice in the newest version, so there's no legacy versions involved. And here is Gmail. I'm not sure if you know it, it's like one tool that you can use to answer emails in the browser, which is absurd, but people use it. And we want to write a message. So we click on Compose, and then naturally the Compose window opens. They were like, yeah, we wanted to copy this one thing from this one document into this email because the boss said so, or it makes sense, or whatever. So we try something here. We say, hello. So now we select this. We do Control-C. We copy this. We go back to Gmail, and we want to put it in here. And we do Control-V. And oops, that's bad. It's like, where does it come from? And how is that even possible? Because that is kind of not making any sense, right? And it doesn't make any sense. So the question is, what did we just see? Like, what kind of sorcery was happening here? Like, where we have an Office software, or we have Gmail, and then an XSS after pasting something like that is crazy. That is witchery. We, of course, want to find out about the technical background. We want to learn what happened here. And why did it happen? And what is the underlying technology that we can do something like this? And how is it possible that we melt two things together that are seemingly unrelated, like an Office software where we copy something from, and a browser where we paste in too? And what kind of thing is this? Obviously, we're scripting here, so it's kind of cross-site scriptish, but we don't really have sites that script each other, so we can't call it XSS. Maybe we can call it cross-application scripting or something like this. And how is it possible at all? So to understand how this is possible, we have to have a look at a very specific part of our operating system, or rather, to be more precise, of the window manager of the operating system that we're using. Because this is where the magic is. Oops. Everybody still alive? Yes. And to do so, we have to walk back in time a little bit, and we have to kind of have a look at how, for example, in the medieval ages, texts and books and manuscripts and documents were edited and preserved. So in the years far, far, far in the medieval ages, when the first books were there and printed and written, sometimes those books would get moist and they had to be repaired. The paper was ruined. Not the whole book was ruined, but only parts of it. So people came and used a scissor or a blade and extracted parts from the existing book and created a collage that would be the new book, to preserve the old work. And they used it by cutting something and then pasting it into the new thing. So we're talking about cut and paste. And even today, there's scissors involved. If you're working in the media industry, you will see that there's a lot of analog technology still around. And then you cut things and you paste them somewhere else. And this is, of course, quite useful. And of course, in computers, this technique and basically this behavior was adopted. This is Apple's Lisa, and this is one of the first computers actually actively supporting something like cut and paste or even copy and paste. So you can copy something, then you had it in some temporary storage, then you paste it into something else, and you could use it. But of course, it's just text. But however, this computer was the first one that actively called it the clipboard. And with clipboard, I'm referring to the location where this data is being stored. Because you cut something, it's got to be somewhere for some time, and then it's got to be fetched from there and used somewhere else when you paste. And if you dig deeper into the origins of that clipboard, you will find out that there's a bunch of white papers and tech reports, and some of them came from IBM. And IBM was nice enough to say, like, okay, we're going to specify this and this and that, and it should look like this, and should be like a storage container for a bunch of different formats that we can use in different applications. Then Microsoft trolled it a little bit and said, like, okay, that's a cool technology, and thanks for the free white paper, let's put a patent on that. And they indeed patented it. And Microsoft Windows 3.1 was the first operating system where you actually had complex copy and paste. Complex means that you have the possibility to store several objects in the clipboard, not just one single object. If you copy something, you might think, okay, there is one string of text. But with Windows 3.1, it started to be a bunch of objects that would contain different information, which is interesting. And the clipboard today has not majorly evolved from that. It still is a place where we store intermediate data. So one application where we copy from delivers data, and another application where we paste into takes the data and does something with it. And now, to get closer to this actual security problem that we just witnessed, we have to ask ourselves, like, how does it work? How does it look like? How can we get a clear impression of what we have in that clipboard? How does it look like? How is it structured? And I was looking for quite some time and trying to find out what the answer is to this, and I was running into this old, almost ancient piece of freeware. We don't even have freeware today anymore, it's all online. But it's called ClipView, and I think it's written by a German dude called Peter, and it's effectively a raw clipboard viewer. So it gives you the possibility to have a look at the raw representation of the clipboard's content. And this tool helps us to learn a thing, because as you can see here in the screenshot, the clipboard is not just one object that is holding one bit of data, but it's a bunch of objects that hold different kinds of data that all try to, at best, resemble the data that we copied. So I was also trying to find a tool to do the same thing on Linux, because this only worked on Windows, but then I figured out that this also runs on Wine. So if you want to kind of do the same thing and do the same analysis on a Linux system with like a Linux window manager, just run it with Wine. It's like a very simple tool and it's perfectly fine. However, let's have a look what it actually does. So here we have a text file, and text files are like very simple. They don't contain any markup or layouting or complexity. It's just like raw text. So you would think if you copy a bit of raw text, that not much is going to go on. It's just like one string of text, and that should be one object in the clipboard, but no. As we can see on the screenshot, we have a bunch of objects in the clipboard, despite us just copying raw text from Notepad. We see we have one bucket that we call CF_Unicode text. We have one bucket that we call CF_locale, one bucket that we call CF_text, and one more bucket that we call CF_OEM text. They literally all contain the same data, just in different representations, in case some software comes, receives the paste, and cannot deal with one of the representations, so it chooses another one. But even for text, just like simple raw text, you can see there's a certain amount of complexity. Then you go ahead and, for example, open a Word file with Word 2013, and you copy something from there. And then you have a look at the clipboard, and you realize, oh, this is fairly complex. There's a lot of stuff in here. We have like a data object, object descriptor, rich text format, I love rich text format, HTML format, text, Unicode text, enhanced metafile, picked, embed source, native, owner link, and so on, and so on, and so on. So copying something from the Notepad, 4 buckets are being created. Copying something from Word, almost 20 buckets are being created, all containing different data with the same information, just in different representations. And one of them is already highlighted. I hope you can see it on the screen. And it's the interesting one, at least for my case, and that says HTML format. So that seems to mean that the software where I am copying from is creating different representations of the data that I am copying and creates different formats. And one of those formats is something that the browser can understand. So then the browser would come and would say, okay, I'll just take this one, this particular bucket, because I understand this, and the other ones I don't understand, so I don't choose them. Now, HTML is interesting, and if you see this piece of HTML, you know immediately this is disgusting. Like, everybody who likes HTML, like who actually likes HTML, will see this and be offended, because this is a disgusting interpretation of HTML should look like in the eyes of an Office software. Like, blah. You can see those styles, there's like proprietary stuff in there, it's like weirdly formatted with single quotes and whatnot. This is disgusting HTML. This is HTML that is being produced by Microsoft Office. So kind of no surprise, right? And you can also see that fragments of the text that we composed in Microsoft Office are still in that HTML. Of course they are. It says Justin here, and you're my hero, and please follow me on Twitter, and so on. It's all still there. So we have a connection between what we write in Office and what arrives in the HTML. Maybe we can do more out of that. But to recapitulate real quick how it works, it's essentially very, very simple. You copy from an application. The application decides on its own what kind of buckets it creates in the clipboard. It creates those buckets with different representations of the data that you copied. And then a different application, be it also Word, be it a browser, be it Microsoft Paint, whatever it could be, then decides which one of the buckets to take. Does it understand HTML? Gonna take the HTML bucket. Does it understand rich text format? Gonna take the RTF bucket, and so on and so on. And that is okay. That is quite interesting, and it's not even a negotiation process, just like, hey, let's pick the right one that I understand, I'm gonna be good with that. You can, for example, also copy files, and then you see what the representation is. You get like file handles and pointers to the file system and whatnot, and you copy a lot of things. You can copy sound waves from a sound editor, bitmaps, complex data structures. The application always decides what kind of buckets to create, and maybe the other application where you paste into finds a bucket that it likes, understands, and then deals with that. Now, let's talk about security, because that's kind of why we're here. Clipboard attacks or copy and paste supported attacks are not new. I still remember the old days when there was like the security forums and the web security forums or the Linux forums, and someone would say like, I don't know how to kind of connect my second monitor to my computer in Linux. It always produces errors. And someone says like, oh, you just have to do this one thing. Look, here's the code. Just log in as root and put it in the console. And then you would copy that code from that forum and put it in the console, and then there was text in there with font size 0, and then you were pound. So that is not new. But what is new is that we can actually seemingly create cross-site scripting, and maybe even more, by copying data between applications, completely different applications. Now, how can we do that? And how does it work? That's what we want to find out. Well, the first thing we have to do is look for correspondences. That means we create a file, in this particular case in LibreOffice. We create an ODT file, and we put some text in there. And then we save this thing, we format the text nicely, save again, and then we have a look at what's happening. I wrote a little tool that is online. You can find it at html5sec.org/copy and paste, and it gives you information about the resulting HTML. So you can quickly copy something from somewhere, paste it in there, and then you get more information about how the HTML looks like. And as you can see, the HTML that OpenOffice is producing, or LibreOffice is producing, is not particularly nicer than the crap that Microsoft was producing. So all those Office softwares seem to have their interpretations of how HTML should look like, and you can see that a lot of proprietary stuff is in there. It's not really HTML, just HTML-ish. But you can also see that we have interesting correspondences here, because we see here a string inside CSS. And the string is describing a font name. And that is exactly the font that we have been choosing here. So those correspond. We put a font into the document, we define which kind of font it is, then we copy this thing, we put it into the browser, and we see the font name again. So that is interesting. A, we have correspondency. B, we have a string, and strings are cool. We even see 3 fonts, because there is localization happening. If your office is running in Europe, your default font would be Liberation Song. If it's running in China or in Asian countries, it would be Wenquan Micro High. If it's running in Indian countries and surrounding areas, it's using Lohit Hindi, which is quite interesting, because even if you're not there, the local fonts are still there, but you're never going to see them in the Office document, because they just wait for you to have the right locale. So you kind of have something that is hidden, but still makes it across the copy and paste interaction. So now we need to find out, does it really correspond? And yes, it does. And now the question is, if it corresponds, can we modify the file directly and get more correspondence, have more impact on what is actually arriving in the clipboard and then arriving in the pasted application? Maybe we can. And it's seemingly simple for Office files, because Office files are nothing else but zip files. So you just rename it to zip, and you have a look at the thing, and it opens, and you see a folder structure. In this folder structure, you see a bunch of files, and one of those files looks attractive because it's called styles.xml. And you would assume that in the styles.xml you will find the styles, and indeed you do. Here you will find the folder view, you double-click the styles.xml, you open it with the editor of your choice, and you get a huge bunch of XML. And again, you can see that in this XML file, inside the Office file, you find that particular font name. And you're like, that's cool. Now, if I start messing around with this and edit it manually, then save it again, put it back in the zip file, then rename the zip file back to ODT, open it with OpenOffice, then copy it and then paste it into the browser, maybe it survives. And indeed it does. So what I was trying, I was just like basically saying, okay, we arrive in a style element. We saw this with the original markup that we copy-pasted. So let's be unfriendly and just terminate the style element. As you can see, I do this here. And then after that, let's just start a new HTML element and see if it corresponds. Here I'm using an S element, so everything afterwards should be struck. So I saved this, I re-put it in the zip file, I renamed the zip file again to ODT, I open it in OpenOffice, I copy the thing, I paste it into the browser, and voila, there is indeed struck text. So we can inject HTML into this thing by terminating the style that is being generated by Office, and then it appears on the page. That is pretty cool. That gives us a lot of injection potential. Now, you might think, okay, the talk is over. We know how to inject this right now. Very, very simple. Just put some JavaScript in there or some iframes, and we're going to be done. But this is unfortunately not that simple, because browsers are aware of the risk of receiving something from the outside world via the clipboard, accepting that, and then putting it into the DOM. So I say, yeah, that could be anything in there. So what the browser eternally does is to sanitize this thing. So it runs through a sanitization process, and it strips out everything that is seemingly malicious, including scripts, iframes, applets, embeds, objects. This all goes out. This is not part of the clipboard anymore. All those elements have to leave. It's like, that sucks. So there's a filter. Now we have to bypass that filter. Can we do that? And of course we can, because sanitizers always have a flaw. The question is like, how can you find the flaw? How can you spot it? If you're particularly working in the browser field, you know that you only have to take technologies that are not that well supported yet, and one of these technologies is indeed SVG. I gave a talk about SVG some years ago in this very conference, and actually that helped me, because one of the tricks I discovered back then I could reuse in this piece of research. So this is the bypass. And I think it's trivial, we don't have to explain this, or no, I think we do have to explain this. What we're doing here is we're closing the style element. And with closing the style element, we leave the string, we leave the font name, we leave the style, and we can inject new HTML. We cannot use any script, iframe, embed, object, and something like this, no event handlers, no nothing, but we can use SVG. We create the SVG, then we create another style element. And we have to create style element after style element. The purpose of this many style elements is to make sure that there is a panel that is overlapping everything in Gmail, because I don't want to have like a small spot where people are supposed to click on to execute the JavaScript, because I want the whole window to be infected, of course. So we have a bunch of style elements, and I wanted to put this into one style element only, but then I realized that, I cannot use semicolons because there's a parser bug, and once I use semicolons, the whole thing blows up. So semicolons all of a sudden were forbidden, couldn't use them as characters. So I had to do it like this, and create one style per property that I wanted to set. And you can see I'm making it big, very big height, very big width. I'm making it opaque so no one can see it. And now comes the actual magic. As mentioned, no scripts, no iframes, no nothing that is seemingly dangerous. But what we can do is use a not so well-known feature in SVG that is called animation. We can animate ourselves a link into being dangerous. That means that in the original state, the link is not dangerous. And here we have that link. We can see it has an X-link href, and the href is pointing to question mark. Not dangerous, doesn't hurt. But then we put a circle into that link, so we have like a visual graphic element, and we put an animate element into that link. And we say, hey, I want this link to be animated after some time, ideally 0 seconds, and the element and the attribute that I want to animate is the X-link href. You might ask yourselves why X-link href has to be animatable, but it is, and that is cool. So we animate this starting with second 0 from a JavaScript URI to an ampersand. And the funny thing is that in XML, in SVG's XML, you cannot really use ampersand. But the parser doesn't realize that in time. So what the parser does is it sees like, we want to have an animation, and we want to animate the link to ampersand. Then it sees like, I cannot do this, it's an ampersand, I cannot really do this in XML, I have to escape it. Then it throws an error, and then it animates the link back to the original state that technically never was there before, and it sets it to the from attribute. So this is how we trick the sanitizer, by just like having a harmless state in the beginning, causing an error in the animation, and then forcing the browser to go back to the state that we technically never had, but this is then adopted. So then the link has a new href, and that is a JavaScript URI that is alerting document domain, or document cookie, or doing whatever you want to. So then, of course, we have to escape the whole thing, because we're inside XML. We have to take this whole bunch of code and inject it into the styles XML. Then we have to save the whole thing, and then we copy it, and then we paste it into the browser, and this is the result. This is actual code from Gmail. So you can see we have like a break here. We have a div here that says content editable false, so links turn out to be clickable. We see the battery of style elements we have here. We have the link that has a harmless href. We see the animation, the ampersand, the from value, and then it works. And it works in Firefox and in Chrome. So interestingly, and I don't really know why, both browsers and both sanitizers have been bypassed with the same vector. That was quite nice and saved me a lot of time. So to see this again step by step, what we did was creating an OpenOffice document, renaming it from OTT to zip. We opened this as a zip, opened the styles XML, messed around with the styles, changed the font names, saved it, recompressed it, recalled it from zip to OTT, opened this in OpenOffice, wrote something, copy this, paste this, and then we have XSS. It's a bit complicated, but eventually you get there. And I was like, okay, that is interesting, but it's kind of a niche attack, because it's just like only 2 browsers and only 1 software, and let's see if we can extend this to more software. And I had a look at PDFs. And of course, you can do the very same thing. However, it's different, because PDFs, as we all know, are not zip files. So you cannot just like go into this thing. You have to use a text editor or a hex editor and actually attack this thing. So what I did was, again, open the PDF and have a look for font names, because this is where you want to find yourself, because font names are strings and those you can manipulate. And indeed, I found them. And here we have one example. We see double quote, language, Visual Basic script, on-click alert +1. Why does it look so weird? Why did I have to use Visual Basic script? Well, there is a constraint. In PDFs, a font name can contain all sorts of characters, but it cannot contain parentheses. So I couldn't execute anything, and I had to rely on Visual Basic script to use code execution that does not require parentheses. So that was just a little trick. Luckily, it's future safe, because in the new JavaScript version, ECMAScript 6, you can also use backticks to execute functions, and backticks are allowed for font names. Only parentheses is forbidden, not sure why. So again, we have the same scenario. We create a benign PDF. We open with the hex editor, we find the font names, we mess with the font names, we save the whole thing, make sure that everything's in line, test the PDF if it still looks the same. It does look the same. We copy something from there, paste it somewhere else in IE or in any other browser, and we have the alert. So we can also infect PDFs with this JavaScriptish magic and make sure that whenever someone copies and then pastes something, then this person will be infected with whatever. And I then had a look at Office. And at Office was literally the same thing. So essentially, you take a Word file, be it doc or be it docx, you open it. Doc files, for example, would be openable with the hex editor, and it's like kind of this weird UTF-16 text that is in there. We enter the text that we want to inject, again with the font names. We save it, we send it around, someone does it, someone opens it, copy paste from it, and then this person is infected. With the newer document file that Microsoft Word provides, which is docx, it's a bit easier, because then it's again zip files. So we can rename them, have a look at them. And counterintuitively, the style information in docx files will not be found in actual styles XML, but it will be found in document XML or contents XML. So it took me some time to actually find it, because they had weird file names and it didn't make any sense. And again, we can abuse parser failures, and we can abuse other interesting things that happen inside the browser that enable us to create payload that piece by piece unfolds and then executes JavaScript. Here we have payload that doesn't even make sense. And we see that we have the entity for the quotation mark, and we have a single quote. And that doesn't make sense, because we don't break anything with that, but it still worked, because in the process of converting the data inside the browser, IE had a bug that was converting this one to another double quote. I'm not really sure why, but it did so, and this is how I managed to break out. So that was quite useful. And the result, again, with Gmail is, you can see it, we have the mark up here, we have that thing that we injected, we see that there's this ban, and that there were several attempts of mine to actually get something in here. Most of them failed. This one failed, this one failed, this one failed, but this one did not. So I just tried different entities, different quotes, and eventually it worked. So it was like simple fuzzing against this format, or manual fuzzing. So again, this is quite nice. Step by step, we create a doc, we put a hyperlink in that doc, we then open the doc with a hex editor, we add some HTML around that hyperlink, we make sure that we send it to content editable file so it can be clicked, we save it, we open it, we copy something, the bucket is being created, and we put it into the browser, and then it executes. And the same thing with docx, we just open it as a zip file, inject the stuff, save it again, and it's going to be fine. And the funniest part, because eventually my goal was to extend this to as many pieces of Office software and to as many browsers as possible to have like almost full coverage, was when having a look at XPS. Who here knows XPS? It's supposed to be like the PDF killer, or was supposed to be the PDF killer, but only that it never was. And it's one of Microsoft's ideas to create like document formats that have all resources that they need embedded. And I created an XPS, and I had a look at this thing, and I was like, what is this? This is not really a zip file, this is not really an archive of any sort. I can't find any font names in there, nothing corresponds, everything looked like garbage. It's like, that sucks. So I had a look at the specification of XPS and tried to find out how those XPS files are being created. And it turns out that they use a proprietary compression algorithm, and I was kind of far too lazy to learn this compression algorithm and be able to edit this manually or with a script. So I thought of a different way. And this different way was fairly easy and straightforward. Because the specification of XPS says, well, you can embed stuff. And for any font that you use in the document will be embedded as well. So, okay, fonts, that's cool. Then I'm just going to create an evil font. And I downloaded some open source font from somewhere on the internet. And I used my favorite tool for that, which is FontForge. And I opened the font, and I had a look at string properties inside that font, inside the font's metadata. And I found out that, for example, there's one property set that is called TTF names. And there's a bunch of things in there, like the copyright information, the dude who created the font, the version, and some other things. And I decided, why not edit them all and see which one comes through? And it turns out that precisely the property English US string for preferred family is the one that arrives in the markup if you copy and paste. I do not really know why, but it does. So the process was easy. I take a free font from somewhere, I modify the properties, I install it on my own Integra system, I create a document using that font, I save the document, I export it as an XPS, so the font is embedded, including the malicious font name. Then I send this document around, someone copies something from that, something is being pasted into the browser, the malicious font name is included into the paste, and then we have an XSS. And this particular situation was quite funny because the XSS didn't require any user interaction. I didn't have to click anything. For this particular situation, the sanitizer was off. And I do not really know why, but it was off. So I could just simply use an iframe. And as you can see here, my font name involved an iframe. I was set to content editable false, so it will really execute. And that was it. Like you paste it and boom, immediately JavaScript executes. And you can, of course, embed JavaScript of arbitrary length, which is quite nice. So we have yet another XSS, and I kind of reached the point where I said, like, okay, all Office software is affected. You can modify all Office files of whatever category, of whatever kind, fiddle around with the contents this or the other way, change some things, and make sure that you have an infected document, and inside this infected document, when someone else opens it, there is no indicator that something is wrong. You don't see the font names, you don't see anything broken, you don't get any warnings, it's just a regular Office file. You copy something from it, you paste it, and then it blows up. So we can use PDF to browser, that works, XSS. We can use doc and docx to browser, works perfectly fine. We can use XPS to browser, works, ODT to browser, and so on and so on. So literally all pieces of Office software are affected, and literally every single browser was affected. Some of them are not even more because, needless to say, I filed some tickets, and IE was working on it, Chrome is currently working on it, and Firefox was working on it and is almost done, so some fixes are already out, some are already usable. Yet, we have to update your browsers, of course, and the fixes have to be finished. Chrome is not fully done yet, but they're working on it. And I was thinking, okay, this is interesting. I personally like browser research because I like browsers and it's a great attack surface. But this might also work in other situations. And I played a little bit around and find out that, for example, in Excel, if you copy something from Excel into the browser, you can have XSS. But what happens if you copy something from the browser into Excel? How far can you go then? And I tested with Excel 2013, and they have this amazing new function, or actually it's a formula, and this formula is called web service. So with the web service formula, you can fire a request from the spreadsheet to an external web service. You get the response back, you can map the response to a table, and then you can kind of use XML and XQuery or XPath to actually go into this thing and read certain data and then keep working with them. I'm not sure if this is so useful. It sounds pretty risky to me, and I think Microsoft agrees on that being a risky formula. So whenever you use it in an Excel file and someone opens that Excel file, then there will be a warning first, and we'll say like, hey dude, you cannot do this, or be careful because this tries to connect to an external web service. Do you really want that? And then we click yes or no. Usually no. However, if it comes from the clipboard, then there is no sanitization at all. There is no warning, there is no filters, there is no dialogues. It just requests. So that's cool. So, I mean, I felt like a little bit on crack because the idea was crazy. But what we could do is create a copy and paste intranet port scanner of some sorts. So I combined the web service function with Excel's if. I'm not sure about the current status, but I think Excel has an if, but it doesn't have an else. So the only thing you could do is just like have many ifs. So like, okay, if that call to that web service with the IP address this and this and that, and the specific port returns something, then we have an open port. If it doesn't return anything, then we don't have an open port. And it did this, and it was actually resulting in a huge formula. But if you made it invisible, copied it from somewhere, then pasted it into Excel, it was doing, I need some time, I'm calculating, I'm requesting, and then you get results from that port scan. Because eventually, after it found an open port somewhere, it would issue another web service request inside the if structure, and that would go to you, to your architecture control server, and you would see in the log files that in the intranet that particular part is open, which is quite nice. And it kind of points in the direction where you can go with this, because there's many possibilities for exploitation. And it's not just browsers, and it's not just XSS. Then I was thinking, okay, maybe we can extend the service a little bit and remove the constraint of having a user to be forced to kind of copy something from somewhere. Maybe we can copy for that user without the user even noticing. Well, there's Flash. And Flash is an amazing technology and has almost no security problems, except for this particular one. And that means in Flash, you can fill the clipboard. And you have an API that fills the clipboard for you. And you can even define what kind of buckets are supposed to be created. And Flash allows you to create an RTF bucket, a text bucket, and an HTML bucket. And that's nice, that's exactly what I need. However, to do this in Flash without getting any warnings or any dialogues, you have to have a click. So Flash only fills the clipboard for you when you issue a click. So you need a trusted event, so you need to get the user to click, which is, I guess, not that hard. But I wanted to make it a bit more subtle, so I decided to take a Flash file and have a click handler in there, and have the click handler react to a click by filling the clipboard with arbitrary garbage and some payload. And then I took that Flash file, I embedded it in a PDF file, because PDF can, of course, embed Flash. And then I took that PDF file, and I clicked somewhere in this PDF file, I had the click, I recycled the event a little bit later, I filled the clipboard, and I had the feeling that it was really copy and pasting something, or first copying something, but what actually happened in the background was Flash filling the clipboard for me with something completely different. And then I went to the browser or to whatever location, I pasted it, and it was my payload, but not the payload that I actually believe to have copied, which is quite nice. So we use just like one single trick, and then it works. Speaking of which, all the course material, like all the talk material, is on GitHub. You're going to see the link later on, so you can grab those files, you can play with them yourselves, you can optimize them if you want to, so it's all going to be available. Now the question is like, what do we do against that? Because it kind of sucks. And technically, any document that we ever owned could be infected with this already. We wouldn't even know, because those things would be happening invisibly. And for the browser world, I decided to experiment a little bit and write a browser extension. And I used my own project, DOM Purify, which is an XSS sanitizer, as mentioned, and I connected it inside the browser extension with paste events and tried to sanitize everything before it's actually getting pasted. But I'm a really bad developer, and that software is so crappy that I can only recommend to never use it at all. It's just a kind of proof of concept, if at all. And I used to demo this during the last times when I gave this talk, and it always worked at home, but it never worked on the conference. So I was like, okay, no demo, I'm just going to embarrass myself. But I can at least show you the code or the approach that I chose here. It was basically waiting for the load event, then starting to run the extension code, creating a virtual clipboard, which is essentially nothing else but an element, namely a text area, listening for paste events that are happening on the entire page, then redirecting those paste events into the text area, then taking the value from the text area, pumping it through DOM Purify, sanitizing it, and then issuing the actual event. Of course, that is complete nonsense, and no one should ever use that, but it gave me at least the impression that there can be some defense that you can install in browsers. Lastly, you do have to work for the browser vendors to fix this, because the Office people cannot, it's not their job. I mean, they do produce faulty HTML, but I don't see them ever fixing this. So primarily, the browser vendors have to fix their clipboard sanitizers and make things right again. And I mean, this is just like a small piece of the entire cake, because I believe you can do more things with that, and depending on what kind of application you're copying from, and what kind of application you're pasting into, anything could happen. Like, there is no limits. I mean, I have no idea how Office software reacts. I was trying a little bit to kind of get macros back into Excel without any dialogues and stuff like this, but failed. But I'm no Office expert, obviously. And I stuck with the browser research. But I think if you have a look at this, and if you put some brains into that, then you can find amazing things, depending on what kind of software that's being used. So I heavily encourage everybody here to have a look at this thing if you find this interesting, because I'm pretty sure that there's a lot of OD. And people do copy and paste. I do copy and paste interactions all the time, day by day. Another defense would maybe, for example, also be to use Control-Shift-V, but honestly, I am so used to using Control-V that I wouldn't just like think of this in the particular situation. Some people told me after the talk that they actually use the notepad, and the notepad is continuously open all the time, and whenever they copy and paste something, they always do it via the notepad, from the application into the notepad, from the notepad into the other applications. Like, oh, right, sure, where goes your productivity? So people do use copy-paste a lot, and people do trust this whole thing, and it is transparent. We have no idea what's going on in the clipboard unless we explicitly look. So as mentioned, I think there's a lot of stuff to explore. And yeah, just a basic conclusion. If you do copy and paste, be careful. Anything could be in there. If you copy-paste into the browser from any other external resource, be extra careful, because you have no idea what could be in there. Could be XSS, could be some leakage, could be anything. So that is pretty much it. And if you want to have a look at the proof of concepts, the talk material, and the slides, everything is online. Just Google for the talk title, and you will find the slides. And on the slides, you will find a link, and that brings you directly to GitHub, and there you have all the files to play with, all the PDFs, all the docs, all the doc access, the Excel file, the port scan, and the Flash. Play with it, let me know if you like it, and that's basically it. Thank you very much.